Okay everyone, the second video for probability is very short. It's probability with playing cards. So I'm going to cheat again and use a video that I made before, and I have no clue why I did this, but I filmed this video with me, a video of me down here. So soon this lovely picture of me will turn into an actual not so lovely video of me. Here I am making my video. Okay, there we go, playing cards. So lots of probability questions involve cards, and I know by the time you get to grade 8 some of you are used to playing lots of cards, maybe with your families, your friends, and others of you maybe haven't played as much. So I just wanted to go through the cards there are in a standard deck. Okay, and then we'll just do a couple questions and we'll be good. So in a standard deck of cards there are 52 cards. You don't include any jokers. Okay, there's 52 cards total. Now some of the cards look like this. What are those called? Those are clubs, right? So you have 13 clubs, and well, I'll put them like this. Here's your club. That's my feeble drawing of a club. And what's the lowest one in most games? Usually the lowest one's your ace, right? The 1. Sometimes aces can be high, but aces are often low. It goes ace, and then we go 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what comes after the 10 in cards? After 10 comes Jack. Then you get your Queen, and then you get your King. And those are your 13 cards. Okay, for 13 clubs. Okay, let's look at this. These are called suits, by the way. The clubs, you know what these ones are called? Spades, right? How many of those are there? Well, 13 again. There's 13 spades. I don't know if it's better if I do the symbol or if I write the word. Probably I should do both. Anyway, what are the 13 spades? Well, it's pretty repetitive. You have an ace, you have a 2, a 3, a 4, dot, 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 all the way down to Jack, Queen, King. Exactly the same. You have 13 of them. Okay, those are all the black cards. In other words, you have a total of 13 plus 13, 26 black cards. You also have 26 red cards. Some of them look like this. Guess what that's called? That's a heart. You knew that. Okay, so you have 13 hearts. Do I have to write them down again? You have an ace, you have a 2, a 3, dot, 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 all the way down, and then at the end you have your Jack, Queen, and King, and finally you have these guys. What are those called? Diamonds, just like they look. So 13 diamonds, and just like before, you have from ace all the way down to Jack, Queen, King. So you have 26 red cards. 13 and 13 is 26. 26 black, 26 red, etc., etc. What else do I need to tell you? These cards down here, the Jack, the Queen, the King, are all called face cards. Why are they called face cards? Why am I writing face kids? They're all called face cards, and the reason they're called face cards is because all those cards have faces. Jacks have faces. Do I have? Oh, I don't have any here. But you know, there's actually people on those, drawings of people on those ones, so they call them face cards because they have faces. All the other ones don't have faces. They just have numbers on them. All right, so just a few questions and I'm done. If they asked you a question like, what's the probability of picking, you know, you have a pack of cards and you shuffle them all up and then you take the top card. What's the probability that that card is a heart? Well, remember how the probability formula works? The bottom number is how many different possible outcomes are there? How many total outcomes? Well, there's, how many cards did we say? 52. Your bottom card is going to be 52, a lot in today's homework assignment. How many of those outcomes are favorable, like actually are hearts? Right here, there's 13 of them. So you get 13 over 52. Now here's the thing, 13 and 52, you can actually put that in lowest terms. 13 divided by 13 is 1, 52 divided by 13 is 4. I can give you a kind of a faster way to think of it. If you ask of any suit, because there's an equal number of clubs, there's an equal number of spades, there's an equal number of hearts, and there's an equal number of diamonds, the other way you could have done this is you could have thought, well, how many different outcomes are there? There's 4 different outcomes: clubs, spades, hearts, diamonds, so that's the 4 on the bottom. And how many of those outcomes are favorable? Just 1, the hearts. You can do that because they're all equal amounts. If there was like 12 and 13 and 15 and 11, you wouldn't be able to do that. But you can do that for most of these questions because there's equal amounts. Okay, let's do another one. Let's say I want to know what's the probability of getting a 7. Okay, well, how many cards are there total? How many total outcomes are there? 52 again. How many favorable outcomes? Well, that'd be all the sevens. There's 1 7 that's a club, there's 1 7 there's a spade, there's 1 7 that's a heart, there's 1 7 there's a diamond. So it's a total of 4. Again, you can put that into lowest terms. 4 divided by 4 is 1, 52 divided by 4 is 13, so 1 out of 13 is your probability. And you can do the same thing again, because you have 4 aces, 4 twos, 4 threes, 4 fours, 4 fives, etc. If you're looking at for the probability of getting a 7, how many different outcomes are there? There's 13. There's aces, 2s, 3s, 4s, 5s, 6, 7, 8, 9, 10, jack, queen, king. That's 13 total. And how many of them are favorable? Only one. Only the 7s are favorable. And again, that's because there's equal amount of aces, equal number of 2s, 3s, 4s. You can't always do that. All right, let's do 2 more. Let's say, what's the probability of getting a red queen? Okay. How many total outcomes are there? Well, there's 52 cards, so 52. How many favorable outcomes are there? Well, those would be the red queens. Here's one red queen, here's the other red queen. That's it. 2 out of 52. Put it in lowest terms. 2 divided by 2 is 1. 52 divided by 2 is 26. So there's your answer. Okay, last one. What's the probability of not getting a face card? Okay, not getting a face card. All right, well, how many cards are there total? Total outcome, 52. How many of them are favorable? Well, the only ones that aren't favorable are all these face cards, so we'd have to count up all the other ones, right? We have to count up all these ones. How many is that? Well, it's 10 here, 10 there, 10 there, and 10 there. So that's a total of 40. Oh gosh, how do I put this in lowest terms? 40 divided by 4 is 10. And 52 divided by 4 is 13. So that would be your answer for that one. Okay, Virtual Me is back again saying bye-bye. Hope the video went well, and let me know if you have any troubles. See ya!